All right, get ready, because today we're going to take a deep dive into Kotlin.
Sounds fun.
Yeah, we've got some excerpts sent in from Kotlin in action.
Oh, cool.
And what's really neat is that the authors of this book were on the Kotlin development team for 5 years.
Wow.
So this is straight from the source.
Yeah.
And what we want to do is try to give everyone, a better understanding, like that aha moment of what makes Kotlin special and why everyone's talking about it.
Well, and I think what's interesting, reading through this book is how it's positioning Kotlin.
Yeah.
It's not trying to say, hey, ditch Java and do everything in Kotlin.
Right.
It's more like, hey, this is a really great complementary language, and here's why.
Yeah.
It uses the words concise, safe, and pragmatic to describe Kotlin.
Yeah.
And, imagine if you can write code that is sleek, reliable, it gets the job done efficiently,
Yeah.
and it works alongside your existing Java projects.
That's really appealing.
Yeah.
So it's not about creating, a new language war.
Right.
It's just about, giving people better tools to build stuff.
Absolutely.
And, I always love to see, some code and how things work in practice.
Yeah.
And they have this little snippet where they define a data class person.
Yeah.
And it's just amazing how much they can do in, just these couple lines of code.
Right. And that's a great illustration of Kotlin's conciseness.
Yeah.
You're defining the class itself. You're defining the properties of that class. And you are even handling the fact that age might be null.
Yeah.
Right? With that int there. And you're giving it a default value.
Right.
And then even the way they embed data into the output is super elegant, using what are called string templates.
Yeah, yeah.
It's all about efficiency and readability in Kotlin.
Yeah, it's really neat.
Yeah.
So just getting a little taste.
Yeah.
But where does Kotlin really shine? What type of projects is this really, meant for?
So the book highlights a couple of key areas.
Yeah.
First is server-side applications. So think of the logic that powers web apps behind the scenes.
Yeah, yeah.
Kotlin is a natural fit there.
Okay.
But then, and this was huge, Kotlin is officially supported for Android development.
Oh, wow.
That was a game changer.
Yeah.
Because it really opened up Kotlin to this massive audience.
Yeah, so it's extending the possibilities.
Right.
It's not like, oh, you got to rewrite everything now. It's like,
Yeah.
oh, here are more tools to build cool stuff.
Exactly.
So now, we have listeners of, various technical expertise.
Yeah.
So maybe we can just define really quickly what static versus dynamic typing is,
Okay.
and why that's even important to someone that's not a super hardcore programmer.
Sure. Think of it this way.
Yeah.
With Kotlin being statically typed,
Yeah.
it's almost like having a built-in grammar checker for your code.
Oh,
It catches errors before you run the program,
right.
which can save you a lot of frustration and those debugging headaches later on.
Yeah. Everyone hates debugging. Okay, so less debugging headaches. Sign me up.
Right.
But I always thought that, statically typed languages can be kind of verbose. You have to write a lot of extra code to define the types.
Yeah, yeah. So this is where Kotlin gets really smart.
Okay.
They use something called type inference.
Okay.
So the compiler is clever enough to figure out the types for you in most cases.
Okay.
So you don't have to explicitly write them out. So you get that safety net of static typing,
Right.
but without sacrificing the elegance and conciseness of the code.
I like that. That's cool.
Yeah.
So that makes a lot of sense.
Yeah.
But, how does all of this really apply to the real world where, most development is working with, existing systems and code?
Yeah, that's a really crucial point.
Yeah.
And the book stresses this, most of the time you're not building things from scratch, right? You're working within an existing system.
Yeah.
And Kotlin excels at integration.
Okay.
Whether you're working with frameworks, libraries, or even legacy Java code. Yeah.
Kotlin is designed to play nicely with those things.
I like that. It's evolution, not revolution. It's
Yeah.
let's just work with what we have and make it better.
Yeah.
They even have this little snippet, fun render person list.
Oh, yeah.
And it's a little hint at Kotlin's potential for DSLs, domain-specific languages, which sounds really way out there, but really powerful.
It is very powerful. But before we go too far down that road,
Yeah.
let's back up a little bit and
Yeah.
talk about how Kotlin actually runs.
Okay.
Because Kotlin has its own runtime library, which
Yeah.
is essential for executing Kotlin code.
Hold on, wait. Runtime library, do I need to become a build system, expert now to, like, use this?
Not at all, no.
Okay, good.
Tools like Maven and Gradle handle all of that behind the scenes.
Oh, okay.
So you can even have mixed projects, right?
Yeah.
Where Kotlin and Java code coexist peacefully.
Oh, that's nice.
Yeah, it's all about making that transition smooth, not adding unnecessary complexity. Yeah, no one likes complexity.
Exactly.
So we got, the basics down now.
Yeah.
Let's, talk about some other more meaty stuff like classes and interfaces.
Okay.
It looks like from the book they're very similar to Java, but with a little bit of a Kotlin twist.
Exactly. Yeah, they share some similarities with Java.
Yeah.
But Kotlin adds its own flavor to things.
Okay.
For instance, interfaces in Kotlin can have default implementations.
Okay.
So it gives you more flexibility in how you design your code.
Right. So it's all about like simplifying and streamlining,
Yeah.
like making constructors less verbose so you're writing less code,
Exactly. Yeah.
which usually means less errors, right?
Absolutely. Less code usually means fewer chances for errors.
Yeah.
And another thing I really like about Kotlin
Yeah.
is its emphasis on immutability.
Okay.
So it encourages you to write code that's less prone to bugs,
Right.
especially in those like really tricky scenarios where you have multiple threads running at the same time.
Oh, yeah. Okay.
It's a key principle in modern programming that Kotlin really embraces.
Okay, so classes, interfaces, we got that.
Yeah.
The next big thing the book talks about is, the power of functions.
Right.
So I'm always interested in how languages handle, working with data.
I mean,
right?
be in for a treat.
Okay.
One of the first things that stands out is Kotlin's collections API.
Okay.
Under the hood, it actually utilizes Java's collections,
Okay.
but it supercharges them with a ton of useful functions.
Oh, nice.
Like there's an example they give, join toString.
Oh, yeah. Yeah, I remember that one.
It makes use of things like default values and named arguments.
Yeah.
So it makes calling those functions super flexible and easy to read.
Yeah, it's much easier than some of the other languages I've had to use.
Oh, I'm sure. Yeah.
And then there's this whole concept of extension functions,
Oh, right. Yeah.
which is like mind-blowing. Like you can add functionality to existing classes without having to like change their source code.
That's right. Yeah. It can be incredibly powerful when you're working with large projects or external libraries where you don't have access to modify that source code.
Wait a minute. So we've been saying that Kotlin is like object-oriented,
Right.
but now you're saying function.
Yeah.
So is it both? I'm a little confused.
You've hit on a really important point.
Okay.
Kotlin actually blends object-oriented and functional programming paradigms.
Okay.
It's not an either situation.
Gotcha.
You can choose the approach that best suits your needs for a particular problem, or even combine them.
Right.
And that's what gives Kotlin this versatility.
Can you give us like a real-world example of what that looks like?
Sure, let's say you have a collection of data
Yeah.
and you want to find the element with the maximum value based on some criteria.
Okay.
In Kotlin, you can use a function called maxby,
Okay.
and you define the logic for how to compare the elements using what's called a lambda expression.
Okay.
And that's where the functional side of Kotlin comes in.
Yeah.
It allows you to write very concise and expressive code.
Okay. So I see there's a lot going on here.
There is.
It's concise, it's safe, it integrates, blends different styles.
Right.
But we haven't even talked about one of the biggest pain points, like for developers,
Yeah.
those darn null values
Oh, yeah.
that cause like so many problems.
The dreaded null pointer,
Right.
often called the billion-dollar mistake in programming history.
Yeah, like why?
And this is where Kotlin takes a very deliberate approach.
This is where it gets good, right?
Yes.
I can feel it.
Kotlin forces you to be explicit about null values.
Okay.
So you know which variables can potentially be null.
Right.
And the compiler makes sure that you handle them safely
Okay.
so you don't get those unexpected crashes.
So you're not like getting all these weird exceptions
Exactly.
that just like completely derail your program.
That's right.
And the syntax for dealing with null seems a lot cleaner than like the usual, like, if checks everywhere.
Yeah, Kotlin provides really elegant solutions for this. Like they have something called a safe call operator,
Okay.
which is represented by psi,
Oh.
and it allows you to handle nulls in a very concise way
Yeah.
without cluttering your code with a bunch of, conditional statements.
Right.
It's all about writing clear, readable code that doesn't compromise on safety.
I have to admit, I'm pretty impressed with what I'm hearing so far.
Yeah.
It just seems like it's all about conciseness and safety and a little bit of elegance thrown in there.
Absolutely.
That's really nice.
Yeah, and there's so much more to discover.
Yeah.
We've just begun to explore the depths of Kotlin.
Okay.
maybe we should take a little break here
Yeah.
and come back to some of these more advanced concepts in the next part of our deep dive.
That sounds good.
Yeah.
We've covered a lot already, from like its appeal to its use cases, classes, functions, null safety.
Yeah.
So we'll see what else we uncover the next part of our journey through Kotlin.
I'm excited to see what's next.
Me too. Okay, so we're back and ready to keep going deeper into Kotlin.
Yeah, let's dive in.
The book mentions something called generics,
Right.
which kind of sounds a little scary at first. Like,
Yeah.
what are those all about, and why should I even care?
Yeah, don't let the term intimidate you.
Okay.
Generics are a really powerful way to write code that's super versatile and reusable.
Okay.
Imagine you have a toolbox, right?
Oh, yep.
Filled with all sorts of tools, different sizes, shapes.
Right.
You wouldn't want to have a separate box for every single tool, would you?
No, that would be crazy.
Generics are like creating this universal toolbox
Okay.
that can hold any type of tool, regardless of its specific shape or size.
Okay, so instead of writing separate code, for different types of data,
Exactly.
I can use generics to make, a blueprint
Right.
that adapts to whatever I throw at it.
That's the idea.
Less repetition, more flexibility.
Yeah, much more efficient.
Okay, so can you give me, a real example of how this works in Kotlin?
Sure, let's stick with that toolbox analogy.
Okay.
Let's say you have a function that sorts the tools in your toolbox.
Right.
You wouldn't want to write a separate sorting function for hammers and screwdrivers and wrenches, right?
Yeah, no, that's a lot of code.
That would be a lot of code, exactly.
Yeah.
With generics, you can write a single sorting function that works for any type of tool.
Okay.
So in Kotlin, you would represent this using something like list T,
Okay.
where T represents the type of tool, which could be a string, an integer, or even a custom object.
Oh, okay, so T is like a placeholder
That's right, yeah.
that gets filled in later with the actual type.
Exactly.
Okay, that's pretty neat.
Yeah.
But the book mentioned something about these type parameters, like the T we're using.
Yes.
They get erased at runtime.
Right.
What's that all about?
So that's a key difference between Kotlin and some other languages that use generics.
Okay.
At runtime, the specific type information is no longer available.
Okay.
It's like an optimization technique that makes the code run more efficiently.
Gotcha.
But it also has some implications.
Okay, so does that mean I'm limited in what I can do with generics in Kotlin?
In some cases, yes.
Okay.
For example, you can't directly check the type of an object within a generic function
Okay.
using the is operator.
Okay.
Because that type information is gone at runtime.
Gotcha. So how do you work around that if you need to actually check the type at runtime?
So Kotlin has this really clever solution called reified type parameters,
Okay.
but it only works with inline functions.
Oh, okay. Yeah, we talked about those earlier.
Remember how the code for an inline function basically gets directly inserted at the calling site?
Yeah, like a copy and paste.
Exactly. It's like a copy and paste operation for code.
Okay.
So with inline functions, you can actually mark a type parameter as reified.
Okay.
And this basically preserves the type information at runtime.
Okay.
It's like telling the compiler, hey, I'm actually going to need this type information later on, so don't erase it.
Okay, so that sounds super useful,
It is.
but maybe a little bit advanced.
It can be.
Give me a scenario where, in the real world, I would
Yeah.
use this.
Sure, let's say you have a function
Okay.
that takes in a mixed bag of data, maybe strings, numbers, dates, all thrown together in a list.
Yeah, okay. Sounds like a real world situation.
And you want to filter that list and extract only the strings.
Okay.
With a reified type parameter, you could actually check the type of each element at runtime
Okay.
and build a new list containing only the strings.
Okay, now I see how that could be really powerful.
It can be.
Okay, so generics give us code reusability,
Right.
and reified type parameters add another level of flexibility when you need that runtime type information.
That's right.
Okay, the book takes this whole concept even further and starts talking about variants.
Yeah.
Is this where things start getting really, really hairy?
Variants can be a little mind-bending at first,
Yeah.
but the core idea is actually pretty elegant. It's all about subtyping and how it relates to generics.
Okay.
Remember our toolbox example.
Yeah.
A subtype would be like a specialized toolbox, maybe one specifically for woodworking tools,
Okay.
whereas a supertype would be a more general toolbox that can
Okay.
hold any type of tool.
Right, like the classic, a cat is an animal, example.
Exactly.
Okay.
But how does this subtyping idea actually connect to generics?
Yeah.
So let's say you have a generic class called box T,
Right?
where T represents the type of item you can store in the box.
Okay.
Variance determines whether you can substitute a box cat for a box animal, for example.
So if a cat is an animal, you would think I could put it in a box meant for animals.
That's the intuition, yeah.
Yeah, but it depends on what you're doing with the box, right?
You're absolutely right.
Like, am I putting things in or taking things out?
That's exactly what variance addresses.
Okay.
And Kotlin has these two keywords, out and in,
Okay.
to control this behavior.
Okay, let's break those down. What does out mean in this context?
So think of out as indicating that you're only taking things out of the box.
Okay.
The type parameter T is being used in an out position.
Okay.
This means you can actually use a more specific type, like cat,
Okay.
where a more general type, like animal, is expected.
So out allows for like more specific types in this scenario.
Exactly.
Okay.
If a function expects a box of animals,
Right.
you can safely pass it a box of cats
Okay.
because you're only taking animals out of the box.
Makes sense. Okay, so what about in?
So in is the opposite.
Okay.
It means you're only putting things into the box.
Okay.
And in this case, you can use a more general type,
Okay.
where a more specific type is expected.
Okay.
So for example, if you have a function that expects a box of cats,
Okay.
you can safely pass it a box of animals.
Okay.
It might seem a little counterintuitive at first,
Yeah.
but if the function is designed to handle any cat,
Okay.
it can certainly handle a more general animal.
Okay, that's a little mind-bendy, but I think I'm following you.
It takes a little getting used to.
So out allows for more specific types, in allows for more general types,
Yeah,
all related to how you're using the generic class.
exactly.
Right.
And the good news is,
Yeah.
Kotlin often handles this variance stuff for you behind the scenes.
Oh, good. Less for me to worry about.
Yeah, exactly.
Yeah.
But understanding these concepts can
Right.
be really helpful when you're working with more complex generics.
Okay, I'm feeling like I'm getting a grasp on this whole generics thing.
Why?
So what else does the book talk about in this area?
So they also touch on something called star projection syntax,
Okay.
which is a handy way to work with generics
Okay.
when you don't know or care about the specific type.
So it's like saying, hey, anything will do.
Exactly. You use a method to represent any type.
Okay.
It's like a wildcard.
Okay.
But keep in mind, you can't call methods
Right.
that require a specific type argument when you're using star projection.
Right, because you don't know what you're working with.
That's right.
Okay, so generics, variance, star projection.
Mm-hmm.
My brain is definitely getting a workout here,
Good. A good mental exercise.
but in a good way.
Yeah.
So we're building up our understanding of how Kotlin works with types.
Absolutely.
And speaking of like adding information to our code, the book talks about another like key aspect of Kotlin,
Yeah.
annotations.
Annotations, right.
The little @ symbols
Yeah.
I see everywhere.
Yeah, they can seem a little mysterious at first.
Yeah, what's the story behind those?
So annotations are actually pretty straightforward once you understand what they're for.
Okay.
They're basically like adding metadata or extra information to
Okay.
parts of your code,
Okay.
like classes, functions, parameters, even individual expressions.
So it's like adding labels or notes
Yeah, think of it like that.
that don't affect the actual like core functionality of the code,
That's right.
but like provide some additional context.
Exactly. Annotations can be used for a variety of purposes, like marking code as outdated,
Okay.
giving instructions to the compiler, or even providing information to tools and frameworks.
Okay, can you like give me like a specific example of what that might look like in Kotlin?
Sure, let's say you have a function that's no longer the best way to do something,
Okay.
but you can't just delete it
Right.
because other parts of the code might still be using it.
Oh, it can get messy.
You can use the @deprecated annotation
Okay.
to mark it as outdated.
Okay.
And it would look something like this. @deprecated. This function is outdated. Use new function instead.
No.
Fun old function.
Yeah.
So you're basically putting up a warning sign
Yeah.
that says, hey, there's a better way to do this now.
Use this instead.
Yeah.
So the Kotlin compiler
Right.
and like other tools like IDEs
Mm-hmm.
like actually understand these annotations.
Exactly.
So the compiler might like, give me a warning
Right.
if I try to use this like old function.
Yeah, it'll say, hey, you probably shouldn't be using this anymore.
And an IDE might even like, suggest
Yeah, give you a quick fix.
like, hey, use this new one instead.
Exactly.
That's cool. So it's like a communication channel
It is.
between the developer
Right.
and the tools
Yeah.
that are like, using the code.
that are working with the code.
Yeah, so it helps like make the code more maintainable
Absolutely.
and prevent errors down the line.
Yeah, exactly.
Okay, that's really neat.
And Kotlin takes annotations a step further than Java.
Oh, okay.
You can actually apply annotations to a wider range of targets,
Right.
including like entire files
Wow.
and even individual expressions.
Expressions,
yeah.
like a simple calculation?
Yes.
Or a variable assignment?
Any of those, yeah.
Okay.
So this granularity gives you a lot more flexibility.
Okay.
For example, you could annotate a specific expression to provide hints
Okay.
to a testing framework or a code analysis tool.
That's pretty cool.
Yeah, it gives you a lot of control.
Okay, but how are these annotations actually, like, defined?
Yeah, so you can actually define your own annotation classes in Kotlin,
Okay.
just like you define regular classes.
Oh, wait.
But instead of using the keyword class,
Okay.
you use annotation class.
Gotcha. So it's like creating, like, my own custom metadata type.
That's a good way to think about it.
Okay.
Yeah.
And what kind of information can I, like, actually put into an annotation?
That really depends on what you want to use the annotation for. You can define properties
Okay.
within an annotation class
Okay.
to store values,
Okay.
which could be simple types like strings or numbers
Okay.
or even other annotations.
Annotations within annotation.
Yeah, it can get pretty meta.
Now we're going meta.
Exactly. But the key takeaway is that annotations allow you to add this declarative information to your code,
Right.
make it more expressive,
Okay.
and guide the tools that are working with it.
I'm starting to see how annotations can really enhance, like, code clarity,
Absolutely.
maintainability.
Yeah,
But I have a feeling there's, like, even more to this story.
there is. Yeah.
What about those meta annotations you mentioned earlier? Like, what are those all about?
Yeah, we haven't even touched on those yet.
My brain's getting a little full, so
Yeah, it's a lot to take in.
maybe we should save meta annotations and the rest of this annotation adventure
Okay.
for the next part of our deep dive.
That sounds like a good plan.
Okay, so we're back for the final part of our Kotlin deep dive.
Yeah, looking forward to wrapping things up.
Me too. And you know, we've been through some pretty, like, dense topics.
Yeah, we have.
I feel like I'm getting a lot more comfortable with generics and annotations now.
Good, good.
But we left off on a bit of a cliffhanger, those meta annotations.
Oh, right. Yeah.
So, are you ready to demystify those for us?
Absolutely. So remember how we talked about annotations being like adding metadata to your code?
Yeah, like extra information.
Right. Well, meta annotations are like adding metadata to your metadata.
Whoa.
It's like setting up the rules for how your annotations should behave.
Okay, so I'm picturing like a control panel for my annotations.
Yeah, that's a good way to think about it.
So what kind of controls do I have here?
One of the most important meta annotations is at target.
Okay.
It's used to specify which elements in your code an annotation can be applied to.
Okay.
So we talked about how annotations can be attached to classes, functions, parameters, even expressions.
Right, right.
At target lets you control that.
Okay.
So it ensures that your custom annotations are used correctly
Okay.
and prevents them from being applied to elements where they don't make sense.
So it's like setting boundaries.
Exactly.
Okay.
Make sure they're used in the right places.
What other controls are there?
Another crucial one is at retention.
Okay.
This one determines how long an annotation is retained.
Retain, like how long it sticks around.
Exactly. Yeah, and there are 3 options here.
Okay.
Okay. The annotation only exists in the source code and is discarded during compilation.
So it's like a note to myself.
Yeah, basically, yeah.
Okay.
Then there's binary.
Okay.
The annotation is stored in the compiled code,
Okay.
but it might not be available at runtime.
Okay.
It's there, but it's more like a hidden message.
Gotcha.
And then finally, there's runtime.
Okay.
The annotation is still accessible when the program is actually running.
So I guess choosing the right one, it depends on like what you're going to use it for.
Exactly.
Like if it's just, compile time checks
Right.
or code generation, then, source or binary might be enough.
Right.
But if I need that information when the program is running, then I got to use runtime.
That's exactly right.
Okay, but how do you actually like access annotations at runtime?
Right. So that's where reflection comes in.
Okay.
It's a very powerful mechanism that lets you inspect and interact with code elements while the program is running.
It's like having a mirror
Yeah, that's a good analogy.
into the structure of your code.
Yeah, you can see what's going on under the hood.
That sounds really powerful.
It is.
So like I could write code
Yeah,
that finds all the functions in a class that have a specific annotation, right?
absolutely. Yeah.
That's cool.
Kotlin provides a really robust reflection API
Okay.
that gives you access to a ton of information about your code. Names, types, annotations, even the bytecode itself.
Wow.
You can explore classes, functions, properties, and much more.
That sounds really useful, but also a little, like,
Dangerous.
yeah, like, I could see things getting really messy
You're right to be cautious.
if you're not careful with reflection.
Reflection is a powerful tool that
Yeah.
should be used very carefully
Right.
because it can make your code harder to understand and maintain.
Right.
And it can also have some performance implications.
So when does it, like, actually make sense to use reflection then?
Reflection is often used in frameworks and libraries that need to work with code dynamically. So think of things like serialization libraries that need to convert objects to and from different formats.
Okay.
Dependency injection frameworks that need to locate and instantiate classes based on annotations.
Right.
Test frameworks that need to access private members or manipulate code behavior.
So these are all situations where, like, you need that runtime insight
Exactly.
into the code structure.
You need to be able to see what's going on at runtime.
Okay, I'm starting to see how that fits into everything.
Yeah, and the book actually is a really cool example
Oh, nice.
of using reflection to build a simple JSON serialization library.
Oh, cool.
It shows how you can use annotations to control how objects are converted to and from JSON format,
Okay.
and then how reflection is used to actually access those annotations and perform the serialization.
So it's like a real-world example
Exactly. It's not just theoretical.
of how all this stuff comes together.
Right. It's a real practical implication.
Okay.
Yeah.
Well, I got to say, this deep dive into Kotlin has been an amazing journey.
It has been fun.
Yeah, we've explored everything from the basics of classes and functions
Yeah.
to these, like, more complex concepts
We went pretty deep.
like generics, annotations, reflection.
Yeah.
I feel like I have a much deeper understanding of, like, what makes Kotlin special now.
I'm glad to hear that.
And we only, we've only just, like, scratched the surface here.
Oh, absolutely.
There's so much more.
There's a whole universe out there.
Coroutines and DSLs.
Yeah. Those are some really cool features.
I feel like I definitely, like, want to keep learning.
I encourage you to.
Kotlin seems like a language that's constantly evolving
It is. It's a very active community.
and, like, pushing the boundaries of, like, what's possible.
That's what I love about it.
It's really exciting stuff.
Yeah, it is.
And it's a testament to the power of, good language design
Absolutely.
and, like, a vibrant community.
Yeah, the community is amazing.
So I can't wait to see what the future holds for Kotlin.
Me neither. It's an exciting time to be a Kotlin developer.
Well said. Well, hey, thanks for being such a great guide
Oh, you're welcome. It was my pleasure.
on this journey through Kotlin.
I had fun.
Yeah, me too.
It's always great to share knowledge and learn new things.
All right, well, until next time.
See you later.